Hello, this is Gabe Rogers with Lab 3, Black Hole. The objective is to find the mass of the black hole and the velocity needed to escape its gravity. The concept is Newton's second and universal law of gravitation. And the equations we'll be using is the position and velocity update formulas, the gravitational force, and the position formula. Part 1, finding the mass of the black hole. To do that, we rearranged the gravitational force formula to find the unknown mass of the black hole. So we set the formula as the mass of the black hole equals to the net force times the radius squared over the gravitational constant times mass over the times the mass of the star, which the star mass was 2 to 30 kilograms. And when we solved it out, we got the total net force was 9.4 to the power of 28 newtons, and the black hole mass was 1.4 to the power of 34 kilograms. And what does this mean? The rate of change of momentum and net force are equal to each other, just found through different methods. And the two ways we can find the same thing is dp dt, which is the rate of change of momentum, is the same thing as mass times dv over dt, which also solves to mass times acceleration equals net force. And the rate of change of momentum can be found using just using the planet's mass and velocity, but the net force needs both the mass of the black hole and the planet to find the same thing. Part 2 of the lab was don't crash, and so we had to find the initial escape velocity, which for me was 30 e to the 7th meters per second and -2 e to the 6th meters per second, 0. And my code was kind of buggy, so it went straight through the black hole without much other change. It actually says I crashed into the planet, but I went through the planet, so I was just kind of confused on what happened. And then yeah, my code was just solving for gravity, and using finding, like, we found r hat, and yeah. And the what if question is how fast would you need to enter an orbit around the black hole? And I couldn't find out because the code bugged on me. It probably had to be a pretty large speed, probably close to the speed of light, which is like e to the 7th, e to the 6th, to successfully orbit the black hole from the distance of the planet. Obviously, as the rays farther away, it probably doesn't need to go as fast because there's less of a force. And yeah, that's it. Thank you.